conversation a bit. We've heard a lot of big science end of the discussion. I want to bring it back to the practical coalface of exploration. Okay, we've heard a lot of ideas, you know, one deposit plus two geologists seems to equal three answers. And how do we decipher all that and turn it into a practical application and get out there and do some exploration? And I want to paint for you a scenario. You're doing nickel exploration. 2 years ago you were doing copper and iron ore exploration, but now you're doing nickel exploration. There's already muttering in the winds from investors that it might be a really good idea to do graphite exploration. But right here, right now, today, you'll want to find out how to do nickel exploration. So you don't necessarily come at it from a scientific background in nickel. Sure, you might have done some nickel exploration in the past, in your early years, some kicking around Kambalda or Leinster or Mount Keith or one of these places, very famous here in WA. But today, you want to be a first mover opportunity in nickel. Now, there's a couple of ways you can be first mover. And we've seen a lot of one way to be first mover. Go into a data-rich area with a new model and a new idea and better understanding and see what you can shake loose. Now, the big problem with that from a practical point of view is everybody else is there as well. That ground is tightly held. It's quite expensive to get involved. Sometimes you can't get the backing to do it. Sometimes you can't get the ground you want. So the other way to be a first mover is to get out there into the moose pasture, as we used to say in Canada when I was working earlier in my career. Trouble is, you've got some geological mapping. It's dubious vintage, probably 1960s, 1970s, based on traverses a few miles apart. Air photo interpretation, which doesn't really help you a lot because a lot of it just shows jungle. You've got some stream sediment geochemistry. Trouble is, though, they didn't assay for anything that you're looking for. You've got some satellite gravity data, which could be reasonably handy at that big picture scale. You've got shuttle radar, which is also pretty handy at that big picture scale. And you got really lucky, and you found some airborne magnetic data, black and white contour maps that was 1975 vintage flown at a mile. What do you do next? But WA is expensive, the ground's held. You want to do nickel in WA, it becomes an expensive prospect. So you go out there, you do the big picture targeting, you have some great exploration concepts that have been developed for nickel at that big picture scale, and you stake 7,000 square kilometres. It's up to you now what you do with that in terms of data acquisition to answer all the blanks. So that's where I want to pitch the talk that I'm doing today, is what do you do at a practical level as an exploration geologist to fill in all this data blanks that we don't have to be able to do these great things at the detailed level. And part of that is particularly prevalent in nickel exploration, although we're seeing hints of it all across the place in other commodities today, is, in other words, what are the perils of using a mineral systems approach as a black box? Today's take-home message from me today, mineral systems, the science versus the black box. Fundamentally, what we're hearing about all day today is understand your target. Okay? Otherwise, you'll miss and you'll waste a lot of shots doing so. And this is where we get into that other really great power law curve in exploration, the cost of exploration. Okay? Doing that big picture targeting, that's the cheap part of the business. It gets progressively more and more expensive and more pressure from your shareholders for results as you get closer and closer to drilling that thing. And when you get to the drilling stage, that's when you're at the most expensive stage. That's where everything's on the line. You have to prove that you're in the right spot. We understand random exploration, sure you might get lucky, but you want to provide focus. So all of this is all about focus. But what sort of focus do you provide? Sure, we're out there, we're looking for some sort of nickel, right? That's not necessarily the focus you want. We're looking for this sort of nickel. That's the focus that we're looking for. Now, I've done a lot of my exploration career not in the Yilgarn, just about everywhere else. That's where I've been looking. But here in Australia, we've had one particularly excellent example of a mineral systems process that's been applied to nickel systems in the Yilgarn with a fantastic track record of success. And that success has honed their exploration skills for this type of deposit. But there is an important difference between the appropriately applied paradigms that we've learned from that deposit and universal mantra that we take and try to apply elsewhere. So So that's one of the things I want people to think about today. Particularly because not all nickel sulphides are born equal. The science of our target should lead to the science of the exploration strategy matures and how you interpret the results. So you can focus on what matters, or more importantly, stop chasing what doesn't matter for this particular deposit style you're looking for. Don't waste your exploration dollars on things that are a complete red herring, even though they may work elsewhere. The exploration geologist's toolbox at a variety of scales, a variety of techniques, but what it all comes down to is what is the most cost-effective technique available that dramatically increases your chance of discovery for this deposit that you're looking for. And that choice naturally has to be informed by the understanding of the science behind this particular mineral system that you're looking for. Which really then devolves back to what is the real exploration toolbox, which is this, what we've been talking about all day today, is the mineral systems approach. The science of the mineral systems approach, the physical properties of your system that you need to form that mineral system dictates what techniques you're going to use to search for those physical properties. So here we have two nickel deposit styles, quite dramatically different. The typical Conduits, Mount Keith, Conduits style model on the flow facies on the right-hand side of the diagram. On the left-hand side, relatively simple model of the Norilsk type system, the largest nickel deposit on the planet. But while there are similarities that can be used at that big continental scale, when you get into the detail, there are fundamental differences. And those fundamental differences are going to dramatically change your exploration approach you take. Nickel sulphides in Australia. Being a codes graduate from a long time ago, I know Ross would shoot me if I left Tasmania off this map, so there it is, Ross. Don't worry. The Yilgarn was the scene in one of the first nickel booms. It is a world-class nickel province. We've got, between the various different terrains now of the nickel belt, well over 12 million tonnes of contained nickel metal in sulphide, world-class by any means. It's been the subject of intensive scientific scrutiny, trying to develop exploration strategies for finding more, and that has led to a relatively simple, robust paradigm for exploration that has a really strong and proud history of success. This area has also been the training ground for several generations of explorers here in WA. I'm quite sure there's a lot of people in this room that have done commanding exploration for nickel, or be involved in supporting commanding exploration for nickel. But are the lessons that we've learned here in the Yilgarn universally applicable for nickel exploration elsewhere? Now, I know some members of this audience know the answer to that question and know that the answer is no, they're not. But you're not really the target audience. The target audience are those people that a couple of years ago were looking for copper, zinc, this year they're looking for nickel, next year they might be looking for something else. So trying to sort through that one ore deposit plus two geologists equals three answers type of evolving, shifting goalpost of what we understand about science, and picking and choosing the right target to apply for where we're looking. And that gets important when we start to look at the other terrains there. The Musgraves province, up until the year 2000, we had a fairly good idea. It was prospective for nickel. Now we've got over 1 million tonnes of contained nickel metal there. The Nova Bollinger down in the Albany Fraser. Again, for decades understood to be prospective for nickel. Now we have a rapidly evolving understanding of this as a world-class nickel province. So what have we learned about finding nickel from the Yilgarn? And at a relatively fundamental basic level, and don't worry, no isotopic systems were harmed during the production of this discussion. Nickel sulphide deposits are located on the basal contact of the thickest, most ultramafic plot of the lithological sequence. At its simplest, most fundamental level, that's what we understand about Conduits. And based on this, and where we are in the Yilgarn today in terms of superficial environments, the weathering that's happened, the deformation history, etc., we do have in our exploration data sets of geophysics, geochemistry, and even physical geology flags that we know that we can apply and use to focus the here. So what are the paradigms for Conduits nickel exploration? Well, we find nickel on the basal contact in Doesnt or peridotite ultramafic rocks. Why is that? Well, the black box is that we're looking for thick sequences of IMGO value ultramafic lithologies because we know that this gives you the best chance of finding nickel sulphides. What is the science behind that? Well, it's fairly simple. It's gravitational settling in a stream sediment analogy. We have a ultramafic flow, very low viscosity. If anyone ever wants to see what this thing probably looked like in the real world, I suggest you go to a ferronickel smelter as processing nickel saprolite ores, because this stuff flows like water and probably has roughly, an order of magnitude, maybe more viscosity than water, but several orders of magnitude less viscosity than basalt. This stuff is very, very, very low viscosity. So dense phases settle through it rapidly and easily. So we're in a stream environment. We're looking for the heavy deposition at the base of that stream in changes in flow regime. This is the relatively simple paradigm that we've learned from Conduits. But if we look at sulphide systems, we see straight away that ultramafic rocks aren't necessarily the targets. Right? As we go through the geological ages, we get down to anything as low as maybe 8% NGO content of these rocks. And that has very different physical properties. These sorts of magmas are actually quite sticky. Sulphides don't rapidly accumulate as easily. You need different processes to be able to form massive sulphide deposits. You can even transport massive sulphide by these ores. This ore will actually physically pick up and move massive sulphide en masse. So there are different sets of paradigms that you need to think about. And just to straight away focus on ultramafic rocks as your target environment, you would miss 70% of the world's nickel ore bodies. So that's something to remember. Ultramafic rocks don't necessarily equate to nickel targets. It's a fundamental basic thing, but what I've seen over the years is this automatic, almost immediate reactionary focus on ultramafic rocks as nickel targets, and that's not the case. As we see, we can take essentially any mantle-derived olivine saturated magma to composition slightly above more gives you potential to find a nickel deposit, not just ultramafic peridotite or donuts. In our surface media geochemistry, even peak nickel values in Conduits can actually work in our favour if they have nothing to do whatsoever with the sulphide deposit, simply because you accumulate nickel in olivine. You can have up to 0.3 weight % nickel in olivine. So the lateritic process will concentrate this nickel in olivine and give you a booming nickel signature in your soil geochemistry, sitting right above the rock types you're looking for, the ultramafic thick part portion. So this could be a proxy even just to get you into the environment of the sulphide, even though it isn't the sulphide signature for the nickel. But as we said, chasing ultramafic rocks isn't necessarily going to find you the nickel sulphides. So concentrating on that booming nickel anomaly that you get in soils, maybe 1%, could be completely and utterly drowning out the signature you're looking for. You might be looking for something incredibly subtle that's sitting in a gabbro 2 kilometres in that direction, but the signal is swamped because your focus is straight away into this. You're applying a paradigm for Conduits systems, looking for the ultramafic rocks without really thinking of what the underlying science is behind that. And again, the correlative of the ultramafic rocks is in our regional exploration tools. We all know for Conduits systems that magnetic surveys are probably the best first pass tool you can use to try and focus into where the Conduits are. Why is that? Because we know that there is a strong association between the ultramafic portions and high magnetics. That's the black box. But why is that in the science? Actually, the magnetite you're looking at has got nothing to do with the primary magnetic system whatsoever. It's the pentonization. You're looking at the result of metamorphic destruction of olivine or sufficient groundwater destruction of olivine. The residual serpentinite doesn't incorporate iron into its lattice. So that iron then comes out as magnetite. So the magnetic expression you're looking at has got nothing to do with the nickel forming environment, but just coincidentally sits above the thickest, most ultramafic portion of the sequence. That's where you develop the most serpentinite. If we look at actual magmatic systems, you do not expect to see at all magmatic magnetite in these rocks, particularly in ultramafic rocks, but also moving into the more dolomitic member of the spectrum. It's not until you get up to ferrogabbro, ferrodiorite, etc., that you might expect to see a substantial amount of primary magnetite. But the trouble is, once you get to those compositions, you're outside the nickel forming window, because you move well away from the olivine crystallization time. You fractionated the magma. These two images, same scale, same field of view, the same stretch on the magnetics, both contain 1 million tonne of contained nickel. The one on the left is the Conduits, the typical chain of pearls. bit of a no-brainer on where you'd be looking to take out your tenements. The one on the right, high-grade, upgrade fibrillite facies to granulite facies metamorphic terrain. And the big problem here is that the target rocks you're looking for have no magnetic expression. So how do you find them in amongst this sea of metamorphic magnetite? So the paradigm of using this tool as your first pass to try and get into nickel exploration, it'll help you map a lot of structure, but it might not necessarily help you target the rocks you're looking for. Let's go take it the other way now. We have some tholite paradigms that sort of crept into the literature. Well, crept into the literature in such that never in the way that they were intended. I'm sure Dean Hodson looks at this diagram and sees how it's been used over the years and cringes because it was never his intention how this has been used. And I've seen people talk about this in exploration meetings, so I know this is how they're using it. This is it's sort of like a holistic deposit model for nickel sulphides in relation to other types of deposits. And we see the nickel sulphide sitting in the base of the large layered intrusive series at the base of the ultramafic. Only problem is that this isn't a formation model and it doesn't really exist anywhere in nature. This is just merely a summary diagram meant to offer a contrast in the one picture of different deposit styles. Unfortunately though, I have actually seen this model applied as an exploration model of people chasing the bases of ultramafic intrusions, large layered series rocks looking for nickel. A lot of exploration dollars gone down the drain. So taking what we know from Conduits and applying it to tholiites, and this is what John was talking about earlier, we see that the important part is conduit systems again. Even in tholite systems, conduits are what we need, simply because of the mass flux. There is more metal contained in the sulphide within that intrusive system we see today that can possibly be explained by the amount of magma that surrounds it. So more volume of magma must have gone through that system than what we see preserved. It's a throughput system. High flux is needed. You need to scavenge effectively the metal from that high flux to create your ore deposit of the tonnage we see. So what are we actually looking for in terms of geometry? Well, we're not looking for large layered intrusive bodies at the base of the ultramafics. We're looking for pipes and conduits. I don't know if it's obvious to you guys, but on the left-hand side of that diagram, you see a little scale bar, that's 200 metres. So typically we're looking for deposits, or intrusive systems even, with the deposits inside that intrusive system, where the thickness might only be several hundred metres, and the cross-section might only be up to 1 or 2 kilometres. And the thing with nickel sulphide systems is, by and large, the signature footprint is contained wholly within the intrusive. There is no aureole around this thing. You might have a very narrow metamorphic aureole of the country rocks from the intrusion, but that's about it. Unless there's been significant later deformation that has smeared it across. But in terms of primary signature, it's wholly contained within that intrusive system. So that's the footprint of what you're looking for. In long section, I mean, the world's largest deposits, Talnak and Norilsk, you're dealing with intrusive systems that are maybe 300-400 metres thick, 4 or 5 kilometres in cross-section width in places at the biggest, 15 kilometres long, but also in the Siberian traps, 7 mineralised intrusives, I think they are, out of a total of several thousand. So it's a needle in a haystack job approach to exploration. So the idea of looking at large intrusive systems that's perpetuated into the mainstream thinking doesn't really apply. We are looking for channels. So like I said, today's take-home messages. We have had, I think, a little bit of a culprit bias in Australian exploration because of what we know so well from Conduits and the very large success that we've had looking for Conduits using those approaches. And then applying that to other terrains doesn't really apply, doesn't really flow. There's enough differences at the detail level that you need to be very well aware of what those differences are to be able to successfully explore in a non-Conduit terrain. And like I said, and this is because not all nickel sulphides are born equal. And to bring it up with a fairly topical example that's been in the recent press, looking at the Albany-Fraser zone, we have here a magnetic structure that's been touted in the media as, you know, the thing to have. Does this matter? If you have this, do you have a better chance of finding nickel? Or more importantly, if you don't have this, do you have no chance of finding nickel? If you think no, great. Let's have a chat. I'd like to hear your ideas. If you think yes, great. Let's have a chat. I'd like to hear about your ideas. But unfortunately, some people are falling into, I have no idea, but I'm going to spend millions of dollars doing every single one of them. And, you know, why? Let's have a chat. I'd like to hear some of your ideas. Okay, thank you. The rest of this is just essentially advertising for CSI Global. It's in your handouts. The key contacts, if you want to come and talk to us about mineral systems targeting and how we can help you. And just essentially who we are and where we've been and what we do. Okay, thank you very much.
Thanks, Tony. Do you have any questions? Michelle.
Tony, is there nickel in the type section for Commodity Arts in the Commodity Valley in South Africa?
Not that I'm aware of. I mean, I haven't looked at that specifically myself. I've been in the Commodity Valley looking at other places, and these things were later hydrothermal remobilised nickel that I haven't been looking at in that particular example. I couldn't answer that question, but there are people here in the audience that could. John, for example. Short answer, no.